Question 32. In the UK, industrial ethanol is now produced by direct hydration of ethene. So ethene's got a double bond. Hydration is addition of water as opposed to dehydration, which is removal of water. So I'm adding water across the double bond. This process has largely replaced the fermentation method. What's the likely reason for this change in the method? The direct hydration route produces pure ethanol. It does, so it'll produce one product, whereas through fermentation you might get a mixture of products, especially if it oxidizes some of the alcohol into an aldehyde or a carboxylic acid. So A is correct, but let's just check through B, C and D. The direct hydration route employs milder conditions. No, the water needs to be heated, so it needs to be steam. The direct hydration route does not use a catalyst. Yes, it uses phosphoric acid as a catalyst. And the direct hydration route produces ethanol in a slower reaction. No, fermentation is very slow. Direct hydration route is quick. So the answer is A. Which alkene reacts with hydrogen bromide to give 2-bromo-3-methylbutane as the major product? I think I need to draw that and see that. 2-bromo-3-methylbutane. 2-bromo-3-methylbutane. This is 2-bromo-3-methylbutane here. But 1, 2, 3, 4. 4 carbons butane. 2-bromo, this is carbon number 1, the bromo is at number 2, and the methyl group's at 1, 2, 3. So I've got this, and I've added hydrogen bromide. So if I add hydrogen bromide across this double bond here, then the H will go with the CH2s and leave a plus here, and the Br minus with its lone pair of electrons will attack this plus here, this secondary stable carbocation. So this will form it. So my answer is D. CH3 twice, 2 CH3s, CH, that's a C. It's got 3 carbons around it, so it's got an H bonded to it as well. CH here, CH2 with a double bond between. The answer is D. Which compound can be purified by forming a hot aqueous solution that recrystallizes on cooling? So we usually do it with something like recrystallization, we do it with something like aspirin. I'm looking for a solid. What do we know that's a solid? Cyclohexene, well, cyclohexene is a liquid. Ethanoic acid is also known as vinegar. Phenylalanine is a liquid. Benzoic acid. Benzoic acid, it's got carboxylic acid groups. It's quite a big molecule with a benzene ring, so it's going to have lots of hydrogen bonds. If it's a big molecule, benzoic acid, carboxylic acid group, it's got O's bonded to H's in there, so it's going to have hydrogen bonds. It's got C double bond O's, it's got dipole. So this is definitely a solid benzoic acid because it's got hydrogen bonding, dipole attractions, it's intermolecular bonds, and it's got large van der Waals bonds as well, with it being a large molecule. So D is my solid. Use the data booklet to help you answer this question. Which is the main aspartic acid species present in the aqueous solution of pH 14? That's basic or alkali. Alkalis or bases like sodium hydroxide remove H pluses. H pluses, remember, is acid, so the bases pH 14 will react with acids and remove H pluses. So which ones of these have had the H pluses removed? The answer is D, where the COOHs have become COO minuses. This has had the H pluses removed by a base or an alkali. This one has too as well, but it's a zwitterion, this, where I've got H plus on there, so that will happen at a certain pH called an isoelectric point. So this one, so if I get COO minuses, it's at a high pH in something like sodium hydroxide. Something like this with NH3 pluses has had H pluses added by an acid. This would be at low pH. The answer is D.